Today we're going to go over Chapter 5, Lesson 3, which is proving triangles are congruent by SAS, or side angle side. Okay, so included sides and angles. Included sides are the sides between the given angles. For example, we have segment AB is included between angle A and angle B. Now just to write in what it is the side between the two. Side between two angles. Then we have the included angles, which are equal to the angle where the given sides meet. So angle C is included between segment AC and segment BC. Now this is the angle between two sides that make the angle. So I'm going to write that in. So here is the side angle side, or SAS congruence theorem. So if two sides and the included angle of one triangle are congruent to two sides of the included angle of another triangle, then the triangles are congruent. Here, I'll give you guys an example. We have this shape. Now, it is important that you remember it's an included angle. That is the key word right there. We can prove these two triangles are congruent because, so triangle ABC is congruent to triangle, sorry, not ABC, ABE is congruent to triangle DBC because, you guys notice we have the exterior right here, the exterior right here. We have the included angle, and then we have another side. So as long as you do side angle side in that order, you will get the correct theorem. Now, order is important. I'm going to go over the first two examples, give you guys a minute to do the other three, and then we'll go over them. Now, I want you guys to keep in mind that this interior side is congruent for the triangles that are touching. That is a mirror side. Mirror reflective side. So you gotta mark it to remember. Now I'll mark it properly instead of just with a squiggle. Just gonna do this. So is A congruent by the side angle side? No, we have angle side side, or side side angle, and that is not side angle side. So therefore, no, this one is not, because it does not have the included angle. We have an angle, but it's not the one that's included. Now for B, again, we gotta mark that mirror reflective side. And here we have the side angle side, side angle side. So yes, this one would be congruent by the side angle side. I'm gonna mark here in little star. Remember to mark the reflexive side. Side angle side. So for C, it is not congruent by the side angle side theorem because we have side angle, which are the vertical angles, but they're not included, so we cannot prove it. Remember, for this next triangle, we gotta mark the reflexive side, which is the one that they share. And we have a side angle side, side angle side. So therefore, yes, it is congruent by the side angle side theorem. And then for the last one, we have angle, angle, angle. They're only giving us angles, so it's not by the side angle side, it's not congruent. So, for example 2, I want you guys to take a minute to realize if there is enough information given to prove the triangle is congruent. If there is, state the postulate or the theorem. Again, we've only learned side angle side, so that would be the one that you would have to do. I'll get you guys started because it tells us that ABE, so this one right here, and CBD, so this one right here. So I'm just going to mark this one in blue. as a shared triangle. Those are the two triangles. Keep in mind the blue part is just a shared, like that. I'll draw them out for you guys first. Now, okay, so this is enough information. By drawing these two triangles, we actually realize they have two congruent sides, AB and BD, and BE and BC. Now, if you realize on the actual diagram, we have the two angles that are congruent right here. Now, that middle one will be congruent because they're shared by the same triangles right here. That is the shared part. So that will make these two angle B's congruent. Since they're both congruent, we have side angle side right here to prove it. We have side angle side, side angle side. So, yes, by the side angle side postulate. Keep in mind that B angle is a reflective angle, and that's the one you have to figure out in order to prove that this is congruent. Example 3, we got to state a third congruence that you would need to prove that triangles are congruent by side angle side. They give us two statements and we have to find the third one, or we have to say what the third one is in order to prove it. So, they're telling us that ST is congruent to YZ, and they're telling us that ST is congruent to YZ, and RS is congruent to XY. Now, the angle for us to prove that, for it to be congruent by SAS, we need to prove that angle S is congruent to angle Y. Now, we can't really prove it, so we're just stating it. S and Y would be congruent, and that will make the SAS theorem true. Therefore, those two triangles will be congruent by the side angle side. So, for this one, I went ahead and just wrote down the statement and the reasons, and the given information into the proof. They're telling us that BC is congruent to DA, and they're also telling us that BC is perpendicular to AD. Now, because you know they're perpendicular, parallel, because I just told you, you guys can actually use alternate interior angles, reflective properties, and all of that stuff to figure it out. So, because we can use those, and they also tell us that the two BC and AD are congruent. Remember, there is the reflective line property that will make that line in the middle also congruent to each other. So I'm just going to go ahead and write, for example, angle BCA is congruent to angle DAC. BCA is this one and DAC is this one. That will be with the alternate interior angles. That's alternate interior angles. So that's how we get that angle to be congruent. Then I already stated that AC is congruent to CA. Segment AC is congruent to segment CA because it's a reflective property. Of equality. And then lastly, now we have side angle side and side angle side. So because we have side angle side for both of the triangles, we can say that triangle ABC is congruent to triangle CDA by the SAS congruent theorem. You guys have homework tonight. It is on big ideas.